Hello, scholars. This is Mrs. Majors from Heron High School. We're going to continue our Skill 3 to Skill 3B. So with 3A, with Mr. Bear, you guys learn how to evaluate the piecewise function, meaning given x values will be y value, as well as be able to come up with the equation of the function, piecewise function, given the graph. Now we're going to go backward. So how are we going to go backward? You will be given the equation of the piecewise function, and you're going to be able to graph this on the graphing paper. Okay, so once again, this is a lot of going to be graphing, so I highly recommend you having printed out the notes like me, or have graphing paper, because we do a lot today. All right, so let's go. So this is a piecewise function. How do I know it? Well, there are three things going on. So I'm just going to use my color because I love color. So first I'm going to graph 1/3 x minus 1 for x is less than or equal to -3 using the pink color. And then my second piece will be y is equal to 2 for x between -3 and 1. And last piece will be y is equal to x squared for x is greater than 1. Alright, so first, let's start with this linear function, y is equal to 1/3 x minus 1. Alright, notice your x restriction, domain restriction, it says x has to be less than or equal to -3. So that's actually the key. So how are we going to apply that? Well, first of all, I want you to kind of visualize what y is equal to 1/3 x minus 1 look like. I know it's a little smaller. So when I ask you to graph that in Algebra 1, what would you do? You'll be like, okay, what did my Algebra 1 teacher say? First, y-intercept. Where is my y-intercept? At -1. So you put your dot at 0, -1. And then you use the information about the slope and build from there. Notice your slope is 1/3. Two ways to think about it. That means 1 up over 3 right. Or you can think of it as a 1 down and 3 left. Right? Because you can either go to the right or left. So either way, let's go. 1 up, 3 right. So 3, 0, 1 up, 3 right, 1 down, 3 left, 1 down, 3 left. And there is my linear function for all of the x's. However, this is the piecewise function. So we're going to cut that off. How are we going to cut that off? What does it say? X has to be less than or equal to -3. So I don't want the whole thing. I only want where x is less than or equal to -3. So go ahead and find where x is -3. Probably somewhere here. So your graph is literally just going to look like this. All right, question. What kind of circle am I going to have at -3 when it's less than or equal to, yes, closed circle. So I'm just going to graph this blue part on my graph. All right, so how are we going to find what happened at -3? Because we got to know what value is at x equal -3. So in order for me to do that, take -3, plug it into your x there. So let's go ahead and find k of -3. Take -3, plug it in, 1/3 times -3 minus 1. -1 minus 1 is equal to -2. That means this point, the starting point is going to be -3 comma y value -2. So let's go ahead and find -3 comma -2. What kind of circle? Closed circle. And now use the information about the slope. How does the slope go? 1 down, 3 left, because we want to check that we only want to graph where x is less than or equals to -3, to the left. So go 1 down, 3 left, 1, 2, 3, 1 down, 3 left, and graph. And I am done with the first part. Probably can't see it. I'm done with the first part. That pink part. Done. Alright, now let's move on to the brown part. The constant function. I have y is equal to 2. So think of how to graph y is equal to 2. If I were to ask you to graph the whole thing, how would you graph? Where is y equal to 2? Just the line right here. Right? The horizontal line at y is equal to 2. However, I don't want just the whole thing. I want only x between -3 and 1. So between -3 and 1. And y value is what? 2. So I'm going to draw my line, not the whole thing, just where x is between -3 and 1. And now tell me, guys, what kind of circle am I going to have? Less than, strictly less than, open or close? Open circle. At 1, less than or equal to, close circle. So there is my second part. Actually, constant function is going to be the most easy one because it's just a horizontal line. All right, last but not least, y is equal to x squared for x is greater than 1. Since this is the first problem, I'm actually going to do the whole thing with you. So go ahead and graph y is equal to x squared. Oh, that's just the basic parent function. Doesn't it look like this? Yeah, so 0, 0, 1, 1, 2, 4. Mrs. Major, how did you know that? Skill 1, duh. Okay, but we're not graphing whole thing. We're only graphing when x is greater than 1. So I need you to find where x is 1. So when x value was 1, what was the y value? 1. If you did not know that, you can actually take that 1 and plug it into x here. Y value is 1. Now at 1, am I going to have an open circle or a closed circle? Open circle. Wait a second. That's already a closed circle. So am I going to make the open circle? Actually, guys, it does not matter. You can just leave it as a closed circle because it's the same. No, it doesn't. All right, recap. Sorry, I was looking at the wrong value. When x value is 1, y value is 1. So I'm going to make an open circle at 1 here. And when x value was 2, y value was 4. And you can keep going, 3, 9. And just draw that part of the piecewise function. So that looks funny, right? Kind of looks like a linear, but not really. It's just instead of giving you whole parabola, it's cut off when x is greater than 1. So that is the end of your graph for that problem. Okay? Review one more time. You're not graphing whole thing. You're only graphing for restricted x values. So make sure you know the overall shape of the graph and cut off the part that you don't need. So let's do one more practice. Okay. All right. Number 1a, graph the following piecewise function. F of x is equal to that. There are only two p's there, right? So x is less than 0 and x is greater or equal to 0. Sometimes you might see a gap between this x value, and that's fine. That's just a matter of who gave you the problem. It does not have to be the same x value. All right. So the first one, y is equal to negative x plus 2. If I were to graph the whole thing, what would that look like? Algebra 1 back. Let's go. Y-intercept 2, slope of negative 1. So that means 1, you can have a 1 up or down, or negative 1 down. Either way, that means 1 down, 1 right, or 1 up, 1 left. Either way. So 1 up, 1 left. Oop. 1 down, 1 right, 1 down, 1. So this is what your linear function looks like. However, I don't want the whole thing. I just want when x is less than 0. So I'm going to cut it off and only going to use this part. X is less than 0. Question, open or close circle? Open circle. So let's go. Y-intercept at 2. 1 up, 1 left, 1 up, 1 left, 1 up, 1 left. Linear function with a slope of negative 1. Perfect. All right, number 2. I have y is equal to x squared for x is greater or equal to 0. If I were to graph the whole thing, that's a quadratic function. 0, 0, 1, 1, 2, 4. I don't want the whole thing. I only want x is greater or equal to 0. So when x equals 0, y value 0, open or close circle? Oh, close circle. 1, 1, 2, 4. So I just need the second half of the quadratic function. So I have a half linear, half quadratic function there. Okay? All right. So that's the end of this part. I want you to do a few problems and then watch the next video.